Here we're going to be taking a look at perpendicular lines. And we're going to start out just by remembering a few things to start out with. One of them is going to be to construct a perpendicular through C onto AB. And there's a couple ways to do it, but being that I'm lazy, I went ahead and traced onto a piece of patty paper line AB and point C. So I'm going to fold AB onto itself, just as I've done in previous videos, through C. And when I do this, what I've done is I've created a perpendicular line that travels through C onto AB. Now I could use the same technique to be able to show a perpendicular bisector, but in this case what I'm going to go ahead and decide to do is use the compass and straight edge. So I'm just going to make sure that my arc of my circle, my radius, is over halfway, and I'm simply going to draw two very large partial circles from point A and from point B. And the two intersections, when joined by a straight edge, are going to give me a perpendicular bisector. Now, one of the reasons to go back and visit this is because now we get into a new theorem called the perpendicular bisector theorem. These points up here that we can call D, and this one down here E, the neat thing that got created is if I was on a coordinate plane, the distance from E to B, this line right here, and the distance from D to B are now going to always be equal. So I know that E is an equal distance from B as it is from A, and D is an equal distance from B as it is from A. This is giving us we've used the construction, but this is the perpendicular bisector theorem, which says if a point is on a perpendicular bisector, like D or E, then it is equidistant from the endpoints A and B. This is going to be helpful for us to remember things so that we can go ahead and work a problem. And I want to be able to break this problem down into some of its parts. So what we've done is created this rather confusing looking sketch with two pairs of parallel lines. It said given that B and D are parallel, so I'll construct my little arrows to show, and C and E are parallel. So since I've already used one triangle, I'm going to use a double triangle here. So we have two pairs of parallels. Then we have a transversal that's cutting through. And we've marked some angles. Angle 1, 2, 3, 4, 5, and 6. What we want to be able to do is we want to be able to find angle 4. What does angle 4 measure? So starting out, this winds up looking like it's very confusing because there's so many lines in here. So to make things a little bit easier, what we want to do is view this picture as parts. And I'm very interested in angle 1 at the moment. So what I'm going to do is I'm specifically looking at CE parallel lines. So I'm going to trace those parallel lines, and I'm going to trace the transversal. I'm going to put that 50 degrees for 1 in place. And if I'm looking at a clearer picture here, where I get some of that work out of the way, I know that this angle and this angle are corresponding. So those are 50 degrees. And these two angles are vertical angles. So those are 50 degrees. So if I come back over into my diagram, I can see that angle 2 is 50 degrees and angle 3 is 50 degrees. Knowing that this is 90, this is 50, and that all three of these together add up to 180 degrees, what I'm able to do is I'm able to say that angle 3 plus angle 4 plus angle 5 are 180 degrees. Now what I'm going to do is I'm just going to simply substitute values. Instead of 3, I'm going to put 50. Instead of, well, angle 4 is angle 4. And instead of 5, I'm going to put 90 degrees because it was given to us in the diagram. Now this is all equal to 180 degrees. So I'm going to combine my like terms. 50 and 90 is 140. I'm going to subtract it from both sides, and I'm going to get that angle 4 is equal to 40 degrees. And this is all using just simply definitions from before and being able to know a little bit about what's going on with some of those perpendicular lines from previously. Another thing that the perpendicular lines helps us with is if I wanted to be able to prove something about a simpler picture. Like if I had just two lines that meet, and I label these and I say 1, 2, 3, and 4. And if I'm told that angle 1 is 90 degrees, what would that tell me about all the rest of them? Well, I know that angle 1 plus angle 2 is equal to 180 degrees. I know that angle 1 is 90. So 90 plus angle 2 is 180, meaning that angle 2 is 90 degrees. I know that angle 1 and angle 3 are vertical, so angle 1 is congruent to angle 3, making angle 3 90 degrees. I know that angle 2 and angle 4 are vertical angles, so that means that angle 4 is equal to 90 degrees. Remember, math rocks with a capital M.